For our third talk today, we have Rephrasing Profanity in Chinese Text from the National Taiwan Ocean University. Shanji?
Chanjie, yes.
Thank you.
Good morning, everyone. Good morning. And my name is Chanjie Lin. I'm here to present my students' work in rephrasing profanity in Chinese text. But first of all, I have to apologize because I have to make examples about Chinese profanity. So there are a lot of curse words in my slides. So I have to apologize if you feel offended. Okay. So profanity is commonly seen in social media when users are anonymous. So nowadays, many systems use simple match and mask method. For example, if you take a profane character in Chinese, it just masked by an X. But we found that a profane Chinese character can also appear in a common word. For example, the word in 干活 or 操作 is a common word. It should not be masked. So that's an issue. And we found that simple masking can also make a sentence incomprehensible. For example, there we can mask many different characters, but when we say it is really X, we don't know what X is, so we cannot understand what the authors really want to say. So here's our approach. Given an input sentence, we want to detect the occurrence of profanity and then rephrase into an appropriate text. And the appropriate text may have to consider the context or the word itself. Yes. So it would be great if this work can be integrated into an input interface of social media. So when you want to write something that contains profanity words, and it would pop up a warning, say that, do you want to rephrase your text into something milder? Yes. So and hopefully it will gradually make a writer to put words more politely, because you have to avoid these warnings. So these are the steps of our system development. We collect the real data from social media, and we label and rephrase the profane phrases manually. And we group these cases and observe them and create many detection and rephrasing rules by hand, because it's just a preliminary experiment. And then we will evaluate the rephrasing rules. So first of all, we have to collect the real data. So the query in fact identify our ability to detect profanity in Chinese. So we just think a lot of major profanity in Chinese. So maybe it does not include all of them, but it has dealt with most of the cases. These queries are terms related to sexual intercourse or something like this. Okay, and the media, social media, come from Twitter and PTT, but we use different strategies there. For Twitter, we just collect the first 30 tweets, because we don't have much time, and the Twitter only show 30 tweets at a time. Okay. And we think that this data set is too small, so we collect data from another media, say PTT. PTT is a famous BBS site in Taiwan, which contains many bulletin boards focusing on different topics. But PTT don't support searching, so we submit queries on Google search, but specifying that the post coming from ptt.cc. Okay. But after we collect lots of posts, we found that the post from gossip board is not useful, because the many cases were proper names, and the haters will replace the name, character in the name, into profane characters. So it is difficult to to recover it, because if we do not know the real proper names. Okay, so we didn't deal with these cases now, but these cases still occurs in other boards, so that's a major error, as we can see. Okay, now so I have to explain our rephrasing rules now. First is rules about F words. The F words will have many uses in Chinese. In fact, the most major tool is we are saying you're just expressing you're angry. So it has we have the writers have already invented many different ways to express these profanity. So it became a patterns. So these are patterns, and you can ask someone's relatives, for example, and you can just use it alone. So our suggestion is that just rephrase it into for oh no or something to express you're angry, but in a milder way. The F word in Chinese can also be an adjective. So as you can see, I felt really angry. So that's a suggestion. But how to distinguish these two cases? And we only detect the occurrence of an adverb preceding it. And we also maintain a list of normal words which containing these profane characters, so that we would not replace these normal words. And the second one is a pattern containing relatives. That's a very particular profane patterns in Chinese. Okay, so you are asking someone's relatives, and these pronoun is also often in the second and or the third person, and any kind of relatives, or even to you can ask your teacher or your boss. So the pattern is very various. Okay. And when it was used alone, it is offensive, and it does not carry much information, so we just removed it. But if it is followed by a nominal, so it is in the possessive case, so you should remain unchanged. For example, I'm saying that his grandmother's specialty dish, so you should not replace it. Okay, the third one is about this word. So we just replace it with bad person, but it can be also an adjective. So we don't have good suggestions, so we just replace it into a milder term with similar pronunciation. Wow, that's an open way we do in Chinese. And the fourth case is about this character. And yes, this pattern, I shouldn't go too much detail about these rules, but I will emphasize the difficulty in rephrasing. For example, this character is not a Mandarin term; it's a Taiwanese term. In Taiwan, we have two major languages, that's Mandarin and Taiwanese. But when we're writing, we're only writing in Mandarin characters. Yeah, so we don't have official characters for Taiwanese, so the user will use many different ways to transliterate the Taiwanese. So before this work, we do not know how many different ways that one can use to write down Taiwanese words, and so this is a good start, because after collecting these data, we will have a set of transliteration of Taiwanese. And maybe these days is not quite complete, but at least it's a start. And there are many usage for these Taiwanese terms. For the first one is this word, it means trash talking, so we just replace it. And as you can see, we have different ways to write down the first syllable, how, okay?
Reinforce sounds.
Oh, reinforce, I like that. And the second one is you go someone to do something, so we suggest another one. And the third one is what, okay, so we replace just with what, okay? And as you can see, we have, there was writing different characters. But there's another special one, special case, that's also a similar sound, with similar sounds. But these two characters can also appear in normal terms such as 3 hours. So we only detect the one which is the term that is at the end of a sentence or followed by punctuation mark. So it's at the end, okay? And the fourth one is annoying, being annoying. So you can see that this character does not mean the real meaning in Taiwanese. We have different meanings. Okay? And if it's really talking about that, we will use a formal term. And as I said, that you can replace someone's name into the profane character. In this case, we just replace it with a baseline term, but you will lose a lot of cases. And that's similar. So I will not go through it, okay? So please see my paper, okay? Please evaluation. Finally, we collect 9,000 Chinese sentences containing profanity from Twitter and PTT, and all were rephrased by human. And we constructed 29 groups of rephrasing rules. And for each rule, we select most 100 sentences to do the evaluation. So it's about totally it's 2,300 sentences. The reason is because we don't have much time. Okay, and it's maybe it's look like an inside test. And rephrasing rules were evaluated in terms of accuracy based on human assessors. But it has to be both correct and fluent. If the reader thinks it's strange, then it is not count as correct. So that's the result of the 29 groups of rules, and totally it's 85% accurate. And as you can see, most of the rules have 90% accuracy. Only 4 of them were below 70. And these main errors are the first main error is out of vocabulary. As I said, that the characters we use to transliterate Taiwanese has many variants. So we didn't collect the complete set. So we're still missing something for this one. As you can see, the consonant and vowels are similar but not the same, and maybe the tones. As you know, we are a tonal language. The tones may be different, either. So these random variants are invented by the internet users. So that's it. And the second one is, as I said, that we will fail if the replaced character, we cannot recover the correct character. And the third one is, well, someone did use these names as their real names for this one, this store. This is a hamburger restaurant in Taiwan, but this term is a profanity in our list. Yeah. And the last one is it's a very strange case. As I said, you are awesome, and noticing you are very different. But it is the order of character will define its meanings. But if the user doesn't put any percentage, it will say you, and it will become you noticing user. So that's incorrect. Okay, so that's our example of the rephrasing and posting on a Facebook wall. Okay, so that we have simple demo system. So you can write and post on Facebook. So as a conclusion, we have collected over 9,000 sentences containing profanity and rephrasing, and we suggested 29 groups of rephrasing rules. And overall accuracy of these rules are 85.56%. And as a future, we want to collect a larger data set, and we might want to use machine learning methods instead of handcrafting. And maybe we can adapt to other languages if possible. And first of all, we did this job before word segmentation. Because the Chinese have to do word segmentation, but we don't have the complete list of these profanity words. So now we have, so maybe we can do that in the future. Thank you.
Questions? Yes.
Thank you. It's fascinating. I wanted to ask you two things. One, whether you are aware of some other profanity filtering experiments and reports on them. For example, Kendra Albert reported on Bull Kitten, which was an effort on Guild Wars to replace a whole series of English language profanities with the word kitten, with some fantastic results, starting, of course, with Bull Kitten. If nothing else, it will make you laugh a lot. And she has a very interesting post, and I believe a paper on that. Secondly, I wonder whether your effort, if deployed, I gather that so far this is research and you haven't yet
No, not yet.
tried it. Okay.
Yeah.
It's not my area, but I have been long fascinated by the wordplay and word replacement that goes on the Chinese internet, very often as a form of resistance to the government, including profanity, like the famous grass mud horse, or the May 35th freedom of Liu Xiaobo, and other examples. Would that affect, do you think, any effort to deploy this among Chinese
I would love
speakers?
to, but I have to find some cooperation. Yes, and I'll just finish this project. So I will do that in the future. I would like to. Yes, thank you.
Yeah, I wanted to ask whether abusive language is always used, or whether profanity is always used to abuse in Chinese, because in English it's not. You can use it for certain functions such as amplification.
Yeah, in Chinese it's not either, because you can we are just want to say it would not notice you. That's not abusive. Yes.
Have one more question. Quick question. Lucas.
So I was curious on the eval. Could you say a little bit about how you did the assessment of things which were? I mean, I guess it's a question. Were you also doing an assessment of things which were not, did not contain profane language, and might you have
Yes,
false
yes.
positives there?
Yes, if the sentence incorrectly rephrased, but it's not profane, but you try to rephrase it, and our assessor think that shouldn't be, so it's not incorrect. It would be marked as incorrect.
So I guess I was really asking, does that 9,000 Chinese sentences contain profane language? Are they all containing profane language, or half of them? Or?
They all containing profane. They all contain profane characters, but they may not be profanity in that sentence. Yes.
All right, thank you. Let's thank our speaker again.
Thank you very much.
For the final talk for today, we have deep learning for user comment moderation with John Pavlopoulos, yes.
So
All
I'm
right, thank
John,
you.
thank you. And this is a work also with Prodromos and Ion. And I'm starting right. Also discuss that news portals and blogs often allow readers to comment on their articles to get feedback, reader engagement and customer loyalty. But often they get abusive language, they get abusive comments, and also discuss that a lot of them close the comment section. To deal with fines and avoid damaging their reputation, portals employ moderators, and moderators often get overwhelmed by the volume of comments. Also readers get annoyed and frustrated and when they see that their non-abusive comment does not appearing online quickly enough because of moderation delays. So a system can directly accept or reject a comment when no moderator is available, for example, if the portal cannot afford a moderator. But it's not realistic to expect from fully automated moderation to be perfect. When moderators are available, it's more realistic to develop semi-automated systems to assist rather than replace moderators. In this scenario, the system assigns a rejection probability score to each comment, and the moderator handles only comments for which the system is not certain about. And the system can also highlight suspicious words, but this is something we discuss in an MNLP paper. So in semi-automated user comment moderation, a system assigns a rejection probability to each comment, and comments with scores above some rejection threshold get directly rejected, and comments with scores below some acceptance threshold get directly accepted. The rest are sent to a moderator to decide. These are the comments in a gray window, and the size of this gray window can be changed by the moderator because he can change what we call coverage, and coverage is the number of directly rejected and accepted comments to all comments. To give an example, a moderator in busy times might want to set a higher coverage value for the system to handle more comments, and vice versa, of course. So to deal with user comment moderation, either fully or semi-automated, we suggest an attentional RNN model, which uses word embeddings and an RNN with GRU cells. Often, the last hidden state of the RNN is used to compute the rejection probability, but we use all hidden states as input to an attentional, self-attentional, basically MLP, computing the attention scores, which after being normalized, they weigh the hidden states, and the sum is used as the final representation to compute the rejection probability. Intuitively, the attention score of a word shows the importance of that word to the rejection probability, or in other words, high attention means suspicious word. We performed various ablations in order to analyze strong and weak points, and first we developed a direct attention RNN, which uses word embeddings instead of hidden states as input to the self-attentional MLP, and the resulting attention scores are used to weigh hidden states as previously. We also use an equal RNN model, which assigns equal attention to all hidden states, somewhat naively. We also implement a direct attention centroid, which uses word embeddings instead of hidden states, and word embeddings are also used as input to the self-attentional MLP. So in effect, no RNN is used here, and we have a weighted centroid of word embeddings. And also we have an equal centroid system, which uses equal attention to weigh word embeddings, which is simply the centroid, a simple centroid of word embeddings. And we also use three baselines. First, detox, which was the previous state of the art, and either applied logistic regression during tuning or an MLP, and selected either word or character n-grams. And a convolutional neural network operating on word embeddings, which is very similar to Kimis et al. CNN. and a simple list-based system using a list of scored words. So the first two we consider to be strong baselines. And I would also like to describe how the two thresholds are defined. So as already discussed, coverage is the number of directly rejected and accepted comments out of all comments, and the higher the coverage is, the system handles more comments, and thus the workload for the moderator is less. Also, semi-automated systems should be evaluated for various coverages, because a system could be performing well for one coverage but not for any other. And for the procedure, first, a system scores each comment from a development batch, and then the comments are sorted. Then we use coverage to infer a gray window. Here for 60% coverage, for example, window of size 2 is used. And the window slides. We slide the window, in effect moving the thresholds, while preserving the same coverage. And we evaluate for each position of the window the ability of the system to direct correctly rejected and accepted comments. Finally, we use the optimal window position and the respective thresholds. Okay, having said that, evaluation. For evaluation, we use precision of rejection, that is the number of comments rejected correctly by the system to the number of comments rejected by the system, and precision of acceptance, that is similarly comments, the number of comments accepted correctly by the system to the number of comments accepted by the system, and we combine the two with the F measure. We use F2 to weigh up precision of acceptance, because moderators are more worried about wrongly accepting abusive text. And about datasets, we introduced a new dataset, the largest publicly available to date, which is it is also an order of magnitude larger than the second largest publicly available dataset, and it contains user moderated user comments from a Greek news portal. I will describe now what it contains: a large training set, an order of magnitude smaller training set, a development set, a large test set, and a smaller test set, which has also been remoderated by multiple annotators. So the second largest publicly available dataset contains Wikipedia talk pages comments, and as you can see, it has a much smaller ratio, a much smaller percentage of rejected comments, but in fact we observe that a news portal can contain much more rejected comments. Okay, and about the results. First, in the Gazeta, which is the news portal the new dataset comes from, we first report ARIA under ROC curve to compare with previous work. And we observe that our model attentional RNN beats the other. And also, interestingly, it surprised us basically to see that the direct attentional centroid, which contains no RNN, is surprisingly good despite its simplicity. And it also outperforms the equal centroid, which simply averages word embeddings and is very common. However, area under curve is only appropriate for 100% coverage. That is a scenario where the system replaces the moderator. However, moderator is often present, so we also show F2, which is appropriate for semi-automated moderation. And we can see in solid lines where the models are trained in the small training set that detox beats CNN and RNN beats the other two, and attentional RNN beats all the other systems. In dust lines where we are trained, all systems are trained in the large training set, the same results apply, but differences are much smaller. And we'll see the same for Wikipedia, the same evaluation measures. But first we should see that all the numbers are higher. Even list performs quite well, above 90%. So attentional RNN does not always perform better than RNN when we evaluate for 100% coverage. However, when we see again F2, we see that attentional RNN is slightly, at least better overall, compared to RNN for all the coverages. I finished quite quickly, so I'll just discuss about my further work and let questions flow. We also have user and user type embeddings that we work, this will be presented in the NLPJ workshop of EMNLP, the forthcoming EMNLP, and we also discuss highlighting suspicious words, also to be discussed in the main conference of EMNLP. And last, we want to incorporate, and we were working on incorporating character-based models, and we also have live demos open on subreddits and YouTube, so you can try it. It's live and you can see at least. Thank you. Yes.
Right, time for questions. Yes.
So, hi, thanks for the nice talk. So I was just wondering, what is the percentage of bad comments in your data sets? Because your F2 metric specifically looks at the precisions only, and if there's class imbalance, then this can actually really encourage the model to moderate less, right? Because if there's only few bad comments and you only take precision into account, then you will encourage the model to accept everything, because rejecting will quickly deteriorate your precision. So have you considered incorporating recall into these metrics?
Well, thank you. So the percentage is small in the Wikipedia, is quite bigger in the news portal dataset, which had a professional moderator. We had recall and we use recall, but there are two reasons for using precisions instead of precision and recall and the F measure. That precisions are quite better to understand from a moderator and use and apply, and also because we need precision of rejection and precision of acceptance, and the rest are handled by this coverage, this gray window. So a moderator could say, give me what you system are uncertain about, and be precise when you accept and when you reject. So this is quite of a difference when you go from an automated, like 100% coverage, to a semi-automated, where recall is handled by this gray zone. But that's a good question.
Can I just clarify this? We do use precision of both classes, right? So we don't just use precision of one class. So
Yeah.
normally usually use precision and recall of one class. We use precisions of both classes.
Thanks. This is really nice work. One of the things that the New York Times is doing is automatically accepting some comments and then reviewing all the rest, not automatically rejecting any. So that would make an interesting point of comparison. It's quite a small one because I think your analysis is pretty detailed, but that would fit that use case as well. Maybe it would be interesting to look at.
Yeah, sure.
I don't know if it's a preview of your upcoming talk, but I'm interested in the highlighting of words, and where the model's correct, that's probably a really great feature, but when the model's not correct, does it make the moderators become inattentive to the importance? You really want to value your moderator's attention, and I'm wondering if you're defeating that by showing them the prediction.
So the question is if we show them the score, if we give them the score and ask for their feedback, or?
Well, yeah, you're probably not highlighting the bad words sometimes if the model's not correct.
True.
And they're going to start looking at the parts that are red only.
Uh-huh. So far, moderators were quite impressed and by the highlighting effect, but that's quite different. We didn't analyze this here. I don't have a proper answer, but moderators usually want to have a quick view from each comment, even if the system say reject it. They don't trust any system at all, but they really need for the system to highlight the right words. If the system is wrong, mistaken, then we have not done this analysis yet, this error analysis. But Ion, by the way.
The EMNLP paper is online, so you can
Yeah,
look.
sure.
And it
That's
includes correlation experiments. So actually we have studied the correlations of the highlightings of the systems, of the system with those of people, and it works. So, so basically,
Thanks. All right. If we don't have any more questions, let's thank our speakers again.
Thank you.
So a few quick announcements. There's a Twitter going, so if you're on Twitter, the hashtag ALW1, so if you want to live blog it, post pictures, whatever, that's the thing to do. I've noticed a bunch of you have already started doing that. That's wonderful. So for the rest of you, well, you get the last half of the workshop to do that. Number 2 is we're breaking for lunch. The poster session starts at 2 o'clock, and the location is basically you go out here, left is the registration desk, right is that sort of break area, and there's poster boards in that break area.
Yes. It's in the back of the break area, sort of to the right-hand side, as far as we know by now. It should be marked. But yeah, so if you go out here, go all the way to the right, to the back, and then...
Yeah, so just take a free poster board and set up your poster. I would recommend, so the poster starts at 2 o'clock. I would recommend that if you're a poster presenter, try to get back at 1:50. And I'll be back, we will all be back there too, just in case, something happens. Everything's usually okay. And then we'll have until 3:30. The machine translation workshop is also setting up its posters, I believe, right as we're ending, so that's when you'll know that we should leave. And then 3:30 is a break, and then we'll be back here for 4 o'clock for Brianna Wu's invited talk and another panel discussion. Conclude with closing remarks. I think that's it. All right, have a good lunch and see you in an hour and a half.